Hi, it's me, Mr. Plumber, and today we're going to talk about steam boilers. We've just completed a steam boiler replacement. This is a replacement only, which means that we just cut out the old boiler and put in a new one. On this particular application, we're converting from oil to gas. This is the new boiler. It's a Burnham steam boiler, and the old boiler was oil-fired. Right here is where we connected to the new steam piping, and all this is the existing. This is the steam header, this part right here. And this part right here is actually what we call the equalizer. And the function of the equalizer is to give the return water, the condensate return water, the same pressure, so that way the boiler doesn't surge one way or the other while it's boiling. And then over here we have the Hartford loop, which basically is more designed for returns that are below the water level of the boiler. In this application, the return is way up high. But we put this anyway because we don't want live steam going up the return. We want only condensate coming back here. So when you deal with steam systems, venting is everything. You don't want pressure on these small residential systems. Pressure is not needed at all. Basically, what you have to do, the way you think about it, is that when a steam system is off, all the pipes are full of air. When you boil the water to make the steam, you have to displace the air that is inside the pipes. And so when the steam boils, it rises up and displaces the air through the air vents. Every radiator needs a functioning air vent, and this is also the main steam vent. This allows the air out after the steam displaces it, and then it stops when the steam hits it. When the steam cools back down and condenses back into water, this opens back up and allows water and air to get sucked back into the system. The displacement of steam per unit of water is something like 1,000. It's either like 1,000 or 10,000 times its volume. So when water boils, the amount of volume that the steam makes is exponential to the amount of water that's in the actual boiler. Again, all boilers should have a backflow preventer, and this is ours, so that way we don't suck back the boiler water. Years ago, you only needed a backflow preventer if it had an automatic feeder, but I put them in anyway. Here's our pressure gauge, or again, you don't want pressure on steam. And there's our glass gauge to monitor the water level. Here's our pressure control safety, which the thermostat is usually satisfied before the pressure control actually kicks in. I have this set extremely low at about 1/2 pound, because again, you don't want pressure on small steam systems and single residential homes. This device right here is our low water cutoff. It's an electronic probe that dips into the water, and it has an electrode that measures the conductivity of the water. And on top of this is a button that you would press to test it weekly while it's firing, to ensure that it does in fact kill the flame. Safety is a big concern when you deal with these gas boilers. You need a spill switch and an overfire switch for rollout. Right here is one of our safety switches. It's a stack switch. And what this does is, if the products of combustion were to come out of this vent damper, there's an element in there that would open the switch and kill the flame to the burner. There's another over-the-fire one, which is a roll switch, which, if the flame should roll out of the combustion chamber, would then same thing. Shut the power off to the controls. These are all, most of the control systems are series circuits. So when one goes out, it kills the next one in line, all the subsequent ones down the stream. Here's our motorized vent damper. And this shuts off when the boiler shuts off. It stops the sucking of the heat out of the system. And this box right here is actually for dilution air. So the products of combustion come out of the boiler extremely hot, and then air comes up this way and gets diluted. And here's our flue piping into our chimney. And there's a chimney connection. This particular job has an existing old oil burner right here that maybe we'll replace in the future. But when you have oil and gas going into the same chimney, you want the gas higher than the oil into the chimney, because if the oil should clog, you don't want to clog the gas also. And that's actually code here in Massachusetts. On this steam boilers are very dirty, and especially when you're doing a replacement, a lot of the cutting oil from the installation and a lot of the dirt from the system needs to be cleaned out of the system. But if you use some of the chemicals, it'll make the problem worse. It'll bring all the junk out of the pipes back to the boiler. So the best way to clean the steam boiler is to just continually fill it and drain it, but you have to be careful, because if you add too much cold water too fast to a steam boiler, you can crack the cast iron. So this is our low point drain, but this is our skimming valve. This skims the floating oil. When oil is in water, it floats on the top. So this allows us to skim the top of the water and just get rid of the oil as best as we can. And that's our steam boiler. I hope you enjoyed it. Thank you. Bye-bye.